In this video, I'll be going over some of 10.1 to 10.3 review problems off the review guide. And so there are a lot of important concepts in these three sections. Section 10.1 talked about finding terms of a sequence, convergent versus divergent series, and summation or sigma notation. All of that is 10.1. 10.2 was over arithmetic sequences, and then 10.3 was over geometric. And arithmetic and geometric had their own formulas. And so just to recap that, for the nth term of an arithmetic sequence, you take the first term and add n minus 1 times the difference. The sum of n terms is going to be n over 2 times a sub 1 plus a sub n, though there was an alternate formula to that. That was n over 2 times a sub 1, and then plus n minus 1 times d. It's basically a combination of these two formulas. But that was arithmetic. For geometric, the nth term was a sub n is equal to a sub 1 times r to the n minus 1 power. In terms of a geometric sequence, and this is for a finite because it says n, this would be s sub n is equal to a sub 1 times 1 minus r to the n power all over 1 minus r. There is another formula to this as well. S sub n is equal to, and I'm going to double check this just to make sure I write it down correctly. So this one is S sub n is equal to, it's a fraction, a sub 1 minus a sub n times r all over 1 minus r. That one I use the least. And then sum of an infinite geometric series. So you can't do this for arithmetic because an arithmetic is always going to be divergent. But for a convergent geometric series, that sum is equal to a sub 1 over 1 minus r. But to double check that it's convergent, the absolute value of r has to be less than 1. So a lot of information thrown in terms of formulas right there off the start. So this review guide is pretty long, just so you have opportunity to work out lots of problems that cover all of these things. For problems 1 and 2, if they want you to find the first 5 terms of the sequence, that is very basic, where if you want to find the terms from an explicit formula, all you have to do is plug in 1 for n for the first term, plug in 2 for the second term, so on, and so on. So this might not be arithmetic or geometric, right? They're just giving you a sequence, and they want to know what those first few terms are, okay? And so I'm not necessarily going to finish that, but you could calculate that. Same thing over here for number 2. If I wanted to find the first term, I get to plug it into a few different places. It would be negative 1 to the second power times 1 over 3 times 1 plus 1. So the first term is going to look like that, whereas the second term would be negative 1 to the third power times 2 over 3 times 2 plus 1. So you just get to plug in the n value to find those particular terms. So you can check those with the answer key. For problems 3, 4, and 5, they want you to do that in reverse. So given the first few terms, write down the nth term as suggested by the pattern. So if I look at number 5, for instance, this is my first term, second term, third term. And if you look carefully, the n value matches the numerator, right? So I could say a sub n is equal to, and then I've got a fraction here with n at the top. But then the denominator, you'll notice it kicks it up by 1, and then it kicks it up by another. So this might be a really good way to write that out. N over n plus 1 times n plus 2. All right, so that's kind of a quick recap of the first page. The second page is going to get into some recursively defined sequences. So for number 6, for instance, they give you the first term. The second term would be, take the n value, which is 2 for the second term, plus 3 times the previous term, which is a sub 1. So that would be 2 plus 3 times negative 2. That would be negative 4. And then to find the third term, for instance, you take the n value, which is 3 for the third term, plus 3 times the previous term, a sub 2, which is going to be 3 plus 3 times negative 4, so that's negative 12, so that's negative 9. And so the pattern goes on because they want you to find the first 5 terms. But in a recursive sequence, be very careful. N is different than a sub n or a sub n minus 1. So n is the value that you're on. So for the second term, it's 2, or for the third term, it's 3. But a sub n or a sub n minus 1 is either the term or the previous term. So for the second term, we use the first, or for the third term, we use the second. 8 and 9 are a quick review of sigma notation, and sigma notation is asking you to add. So in number 9, they want you to start at the 7 and then go all the way up to 9. So I would plug in 7 to start, and then I would add up, and I would do 8 as well. And then I would add up, and I'm going to run out of room, 9. And so I would find all of those separately. So 1 term, 2 term, 3 terms here. And once I find all of those 3 terms, I would add them together. And so let me find my answer key here. All right, so this is number 9. That's going to be 34 plus 46 plus 60 is equal to 140. All right, and now in the bottom of this page, they want you to do the reverse. They want you to write everything out in sigma notation. And so you kind of find how many terms you're going to have. So k is equal to 1 up to 13, and then just kind of see what they're doing every time. What's constant? Well, they're going to multiply by 4 every time. Whereas over here in problem number 11, okay, there's a couple different ways that you can write this out. But in problem number 11, this is going to be, like 1 squared, 2 squared, 3 squared, 4 squared, all the way up to 15 squared. So if I start at k equals 1, I'm going to go up to 15. And that fraction would be k squared over, and now this was a 2, this was a 3, so they're taking the k value and they're adding 1 to it, because it went from 1 to 2, or from 2 to 3. So that's what you're doing here for this second page. All right, and then when you get to the third page, this is where it's going to mix together 10.2 and 10.3, arithmetic versus geometric sequences. And so in order to determine what type of sequence you have, it may be beneficial to find some terms of the sequence. So for example, number 14, if I plug in 1, it's going to be negative 2. If I plug in 2, that's going to be 1. And if I plug in 3, that's going to be 4. So ask yourself, are they adding the same number every time? Are they multiplying by the same number every time? Are they doing something completely different? Other things to kind of note here is if they're adding the same number, it is arithmetic from 10.2. If they're multiplying the same number, it's geometric from 10.3. But if it's neither, then there's nothing really to worry about. You would just write neither. This one, they're adding the same number every time. They're adding 3. So this is an arithmetic sequence. Okay, so some of these are neither. Some of them are geometric. I'll kind of let you decide that. And then on the next page, they're going to get into specifics here. So this whole page is about arithmetic sequences. And so we can answer some questions based off those. For example, The explicit formula that we would use for number 20, let me just rewrite the basic formula here. Here we go. We have a sub n is equal to -3 plus n minus 1 times 6. So then distribute the 6. And then go ahead and combine like terms. So this would be 6n minus 9. Whereas in problem number 23, they want you to find the 50th term. So a sub 50, I'm going to use the same formula from above. It's going to equal to -1 plus 49, 50 minus 1. But then you have to multiply it by the common difference. So what are they adding each time? Looks like they're just adding 2. So you would take 49 times 2, which is 98, minus 1 would be 97. And for problem number 25, they want you to find the sum of the arithmetic sequence. So the formula that I'm going to use here is n over 2 times the first term plus the last term, or you could also use s sub n is equal to n over 2. That's a 2. 2 times a sub 1 plus n minus 1 times d. And actually, I was going to use the first formula, but they actually don't give us the last term. They give us how many terms there are. So for 25, it would be better to use this formula. Your n value is 46. So I'm not going to be able to write this all out. But it would be 46 over 2 times 2 times -1 plus, this would be 45, times the difference, which they're adding 4 each time. Okay, so that would be what you would use for number 25 here. And that is going to be 4,094. And then kind of this last part here about arithmetic sequences, some of these you can work backwards. So for example, number 27, if I tell you that the 15th term is 115 and the difference is 7, work backwards. So we can use this to work backwards. So the nth term is 115. We don't know the first term. The n value is 15, so I'm going to put a 14 times 7. So you would take 14 times 7 and then subtract that from 115. And it looks like my first term is 17. But they might want you to also use the sum formula backwards. So if I write out the sum formula, right, so I know the sum is 790.5. We know the n value is 31, and the first value is 3. What's the last value, right? So I would take 31 divided by 2, which is 15.5, and you can either distribute that or divide it. So 790.5 divided by that number is 51, and then I would just subtract 3 to get my answer, 48. All right, so that's a quick review of arithmetic sequences. Next page here. There's a little bit more with arithmetic sequences. These are kind of the challenge problems here. And then starting at the bottom, we get into geometric sequences where they have you use the explicit formula. A sub n is equal to a sub 1 times r to the n minus 1 power. So these aren't going to require too much work because you can't combine them together. Like you can't take -3 times 5 because 5 has a power. So these right here, not a lot to do. And so the second to last page is probably the most important part over geometric sequences. It says find the indicated term. So this would be find the 25th term. You just have to know what the ratio is. So you take the second term and divide by the first. So 2 divided by -1 is -2. raise that to the 24th power, and then multiply that by -1. That answer is pretty large, negative 16,777,216. And then it says find the sum of each geometric sequence. And so you'll notice that they give you some n values here. So these are finite. So you're going to use the finite formula, whereas here they imply that it's going to go on forever. So you're going to use the infinite formula here, if possible, right? So for finite, I would go the route of S sub n is equal to a sub 1 times 1 minus r to the n power all over 1 minus r, whereas finite is a sub 1 over 1 minus r if the absolute value of the ratio is less than 1. So there are some of those that aren't possible just because it doesn't fit that requirement. But I'm going to stop there just because we've talked about geometric most recently. If you have any questions or concerns over this, just let me know.